Hello, everybody. Thank you so much for coming. Looks like we're already over 100 people live. We will be kicking off in just a minute. We do like to give people about 2 minutes to get past the lovely GoToMeeting download for those that don't use it regularly, etc. So we'll get rolling any second now. But we were actually just chatting right before we started. Dustin's got a project in process here, and we were talking about how it's kind of fun in laser scan because the reflectance of the surface has an impact on the intensity value. So any kind of changes in quality of a surface, like for instance a little bit of moisture, that will make the surface more reflective for the laser, and so you'll get less of a return back. So you can see things like water content in materials, things like that on a surface. So like if you've got a basement wall and you've got some leak issues, wait till it mostly dries out, run a scan, and you'll see actually where the spots are that you've got moisture penetration coming in through your basement wall. So there's some fun stuff there. So
even if you paint over it, Kelly. We had a project where we could see those things that were painted over.
Yeah, because and even after it's totally dry with concrete, because when the moisture evaporates, it leaves behind typically salts and other minerals in the concrete. So there's just all sorts of things like that. It's kind of, you can't see through walls with a laser scanner, of course, but if the thing that you're looking for in any way telegraphs through and changes the material properties on the surface, there's some fun stuff that can come from it. All righty. Well, with that, I think we're probably good to go now. So let's advance the slide and do some quick housekeeping. So yes, everybody else is muted, other than our panelists, of course, unless they make me angry, in which case I'll mute them too. Unfortunately, they can unmute themselves, but whatever. Please ask questions. As we're going, we like to make these things pretty interactive, so we do like to kind of riff off questions coming in from the audience. So I've got the questions panel pulled up. Please, 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 if you have a question that's relevant to what we're talking about, pop it in there. I'll be constantly monitoring that, and if I see a question come in, like the one that just popped up, is this being recorded? Please look at bullet point number 4 on the screen. We will try and answer those questions on the fly. We will do some Q&A at the end, and we'll probably stay on a little bit after time to kind of go through Q&A. We typically get lots and lots of questions, more than we can possibly answer in the hour, so we typically will run a little bit long with those. The webinar is being recorded. Anyone that's registered will get sent the link to download the recording. So if you have to leave early, if you don't make it, if there's a friend of yours that wants to see it, even when it's over, have them register. And in about a week, when we send out the recording, they'll get that link. They can go download it and watch it after the fact if they really, or watch it again if you're, really masochistic, and you just really want to see Larry's hat more. So with that, I think I'm getting heckling from the audience right now as a text. I saw somebody in the audience that said they were going to text heckle me during the call. Anyway, let's introduce our panelists. Larry, please kick us off with a quick introduction, though you are a frequent guest on ScandiBIM University.
Yeah, I'm Laser Larry Kleinkemper. I'm an architect who's been modeling buildings for 25 years, making computer models of buildings. We've been laser scanning since 2007 and doing the ScanBIM sort of process. What else can I tell you guys? I love riding motorcycles. Go Dustin.
Okay. So I've been in the AEC industry for going on 15 years now. Did a lot of civil engineering and then went and started my own company doing laser scanning and high accuracy drone mapping and all the fun toy stuff. And right now I'm also starting a new venture with remote optics, which is live streaming from drones and phones.
And if you notice his fun fact, we have to be careful how many questions we ask him about his work on the Apple campus, because otherwise they will make him disappear. So alas, no previews from scans from the Apple campus on this webinar. Silviu, please say hello.
Hi there, my name is Silviu Stoyan. I've been in the AC industry for 15 years, the same as Dustin. I've been introduced to laser scanning and BIM and modeling, all these cool technology that makes our life easier, back in 2009. And since then, I've been working with Kelly and other professionals to improve these workflows and apply technology to help our sector. Right now, I'm running a company that is focused on building documentation, everything that comes with it.
Go RC Monkeys. And
Kelly, I've just noticed, like in our descriptions and our photos, you and I have been doing this so long that these are like 5 years out of date on both yours and mine.
yeah,
Mine is 5 years old as well. I don't age. You know, Kelly knows that.
yes. Well, that's because you're a vampire, Silviu. But yes, mine, I'm chair of the technology committee now. Ha ha ha. Anyway, I'm Kelly. I'm the moderator and host for today with ClearEdge 3D. Been pulling together this series now for almost not quite a year, but we're coming up on a year of Scan to BIM University stuff pretty soon. So fun times. And not on here is Paula, who is remaining hidden because she's shy, but she's the person that makes all this work. We talked her into being on the photos that we put on social media, so I'll take that as a win. And with that, let's not look at a Q&A slide because we don't need that. Instead, I will stop showing my screen and we will chat. So when we were doing our planning, I was looking for a good Shakespeare joke because, you know, they're ageless. So the first thing we wanted to talk about was to model or not to model. That is the question, because before you go off and spend hundreds, if not thousands of man hours generating models from laser scans, should you? Larry, why don't you kick us off with your thoughts on this particular subject?
Sure. The idea of to model or not to model, you know, we're going through and modeling a building. It may surprise you that not all walls are plumb. They're not all straight up and down. Some of them over time have gone out. Also with floors and structure, it can tend to sag or deflect. And so there has to be a conversation between you and your client as to how to handle those situations. And so there are some situations where you need to show that, but in most situations, what you're going to end up doing, the most common thing to do is to model them orthogonal, or at straight angles with 90 degrees, as opposed to modeling at 89.5 degrees, so that things like your dimension strings work, and other, you know, elements. And it also is way faster and more cost effective to do things that way. So having a conversation with your client as to, you know, what is the tolerance that you're going to model to? How are you going to show those things and express those, that if there is something that's way out of plumb or at a weird angle, you know, how do you want to handle that? That's incredibly important to establish before the modeling begins.
Yeah, and Oh yeah, go ahead, jump in.
Also, I'd like to answer that question because we've had a lot of Kelly situations at the Beck Group. When we worked together, we were doing so many projects at the same time that we didn't have the manpower to always model, and not always was necessary to model. Like just the scan itself, I always tell my clients or people that I interact with, the best as-built is your point cloud. It's not the model, since we are introducing some error when we are interpreting the model, the point cloud. So there are situations where we just need to coordinate the new design to make sure that you're not clashing with the existing conditions. So in that case, I would always encourage the designers to just use the point cloud as a reference in their design model around it, coordinate everything, and now they can even turn that on and print with their drawings if that's allowed. But yeah, there are workarounds, and you can save a lot of time and money by avoiding the modeling portion.
Yeah, because it's a question, right, of both how detailed and how accurate to model, but also, do you even need to model it at all? Is it viable to print with the point cloud? Is it viable to use that as sections? To me, one of the, doing detailed modeling for sections is always something that just takes an inordinate amount of time in any application, right? And if you can use, particularly for detailed elements, and use it in those contexts, it can just save so much time to just get representative model geometry, and then leverage the point cloud. Dustin, what are your thoughts on this? I know you've got plenty of experience with it as well.
I think, yeah, I mean, it's usually the clients are really comfortable working with BIM, at least more and more so. So they usually want to see as much detail as they can till they see the proposal. But the people that I work with the most, of recurring customers, it's really trying to push them to like have that hybrid approach. So what do you really need to show on your 2D plans, and then what can we just use the point cloud as a reference for your design decisions and things like that.
Yeah.
Try to be as efficient as possible.
Yeah, and I'll take this moment to plug one of our affiliates here. But for those of you that don't know about it, the USIBD is a great kind of a great organization that's focused on building documentation. I'm a member. Our company's a supporter. I think Larry's a member, I know, and they have all sorts of wonderful resources to help out with this. And I thought I'd snag a couple images here to pull up, but it's of course not showing the one that it showed originally. But maybe it'll pull it up here. Anyway, but if you go to usibd.org, they make you register to get this thing. But membership is like super inexpensive. It's a couple $100. So anybody that's in this profession, I strongly recommend you go register, because they've got great stuff to kind of help with this, whether it's RFP templates, whether it's RFQ templates, whether it's the LOA and the LOD, LOA specification, which maps nicely to the BIM forum's LOD specification. But it's a great tool to get you to think about the fact that there's no such thing as an LOD 300 model, right? Like, you really need to think about your accuracy and your detail relative to each scope of work, because it's usually not valuable to have an LOD 300 model of certain pieces of equipment, but it might be really valuable to have that of steel structure. Sylvia, I actually think you had something that you might be able to show for that. Let me make you a presenter here.
Of course. Yep.
Oh, did that work? No, it's still angry. Yes, seriously, I didn't just click it by accident. Go to meeting.
All right. Let me know when you guys can see my screen.
We see it.
All right. So this is a very complex project, as you can see here. It's just a box. No, seriously, it's a very complex project. is a box that contains a lot of elements. So you might see here just a floor box and the roof, but if I select this whole model, it has over 2,000 objects. So it's a combination of LOD 300 elements and LOD 400 elements at various levels of accuracy. As Kelly mentioned, we are sending out a like an LOD matrix where clients specify at which level of accuracy and which level of detail certain categories need to be modeled. So I'm going to turn off the building here and just show what's underneath it. So this is a the structure, as Kelly mentioned, is steel. No documentation at all was available. So you can see that here we modeled all the connections with all the bolts, nuts and bolts, as well as any penetrations that we found on the surface of these elements, because the client wanted to calculate the actual surface area of the flanges and the webs of all these members. And this is not a filtered view, but everything is color coded in the presentation view that was shared with the client. Every penetration or every hole can be scheduled, so they can do all those calculations very, very easily. But this whole structure, it might not seem a lot. It takes so much time compared to just doing an LOD 300 model exponentially, or maybe 3 or 4 times more if you're doing an LOD 400 model versus LOD 300 model. So you need to pick very wisely when you sell an LOD 300, let's say not model, but maybe portion of the building to be at that level of detail, because it can add up and it can be very expensive.
Yeah.
So I'll stop sharing, Kelly, and I don't know. Okay. Yeah. And switch back to you.
Yeah. So I just had a curiosity, Dustin. What's kind of the typical LOA/LOD level that you guys normally deliver models in scan to BIM projects? What's your kind of most common customer request?
So we specialize in everything outside the building. We definitely do a lot of like floor flatness scans and things like that. So it really varies. I will just start with that. Some of the tools we use are different. I mean, just with it being a lot more civil work, we're using Civil 3D just as a little bit of a counterpoint. From basic standpoint, if you're delivering anything inside the building, you're probably talking Revit ultimately as a deliverable, and then Civil 3D if it needs to be an Autodesk product, let's say. But yeah, so level of accuracy, we do a lot of different types of projects. We kind of specialize in hard projects, so it's across the board. And then we do get into these conversations a lot of like, what do you really need? Is it an LOA of 30 or 40? Because it seems like everybody wants to send us somebody else's spec for what they're asking for. So it's really then a conversation of what do you really need it for? But 300 is pretty typical inside the building, and 30, LOA 30.
Yeah.
So
middle of the road.
So I want to talk a little bit about that if I can, guys. If you go by the AIA, which a lot of our clients are architects, and they're asking for the AIA LOD, and they look at 200, 300, 400. So 300 is really a documentation level that as you're creating a brand new building or design, and it assumes that you know certain things about specifications and also what's in the building. So when we laser scan, we really can't see beyond the surface. And a wall could be plaster, it could be chipboard, and it could have concrete block behind it. It could have metal stud. It could have wood studs inside the wall. And unless there's a hole in the wall, you can't tell that. Other than the idea of if you're good enough and smart enough, you might be able to work out the math of how thick that wall is at any one point.
But it's an assumption.
Right. And so the honest answer that we probably should be telling our clients is that the LOD is really 200 plus. We're telling you it's a wall. We're telling you it's our best educated guess as to what that wall is made of. But you saying that it's 300 could potentially get us in trouble in a lawsuit. If you don't know what's above that ceiling or inside that wall or inside that concrete that's below that you're scanning. And the laser scanner, I feel like I can't say it enough to clients, is not an X-ray. It's giving us the surface, and then it's up to our professional best guess as far as and knowledge to try to figure out what that might be made of. And then when you talk about LOD 400, like Sylvia was talking about, that's getting into almost a spec sheet level of detailing where, LOD 200 and 300 would not include nuts and bolts, whereas 400 would be getting down to that level like he was showing, that has, that level of construction value and where the exact holes are. So
Larry, that situation worked just because everything was exposed. So you could actually go and take a caliper and measure all of those elements when you scan to take notes.
Right, and so without that, we can't really promise clients LOD 400 unless everything is exposed to that level. And I think all of our watchers today, attendees, need to help. We need to help them understand that.
Yeah, Gus chimed in and said he once had somebody ask if he could scan her arm and tell her if her bone was fractured. Like, nope. Yeah. I mean, on the other hand, like if it like bends like this halfway through, then probably yeah. But I think that's actually a great yeah. That's just how her bone grew. But I think this is a great segue into our next topic, which is getting the model set up right, because Larry and you kind of cued in on the fact that scanning is a wonderful thing, but it captures surfaces. It doesn't capture what's underneath the surfaces, and so what you get is basically a very accurate representation of where all the surfaces are. But actually generating a BIM, which is something that has, not just a 3D model from it, but generating a BIM, there's a whole series of assumptions that modelers have to make. And doing that in a consistent, communicable, documented way is all about model setup and project planning for doing all this modeling stuff. So, there's all sorts of stuff to talk about there. Sylvia, this was kind of your pet topic when we were doing the planning call. So where do you want to start?
In terms of the setting up all those assumptions and observations.
Setting up
in terms of model setup is like, it's a huge topic. Sometimes I personally spend 2 days. Nobody touches the model until everything is set up, from views, filters, naming convention. Everything needs to be set up before we even touch that model. We place the first object. And probably the most critical step of setting up the model is having that conversation with the client. Understanding is, one, do we need to work in their template? Can we work in our template? What are their guidelines? All their Revit guidelines. Can we transpose those and take our families and maybe match their parameters? There's so much that goes into that first initial setup, especially on a large project. So after that discussion, once you have everything written down, you can start working on your model setup. But the first step Even like you can do this, even having the discussion with the client is setting up your levels grid and orientation of the project. One mistake that I've seen a lot is that people like to bring not only, in the building documentation industry, but also in like design, construction, like to bring links in center to center, origin to origin, which, I think is a mistake when you can take advantage of the shared coordinates. So I would always encourage, at least for our industry, to use shared coordinates always to bring in point clouds, but that's challenging because you bring in the point clouds by shared coordinates, it might be rotated, it might be not a zero. So you need to find solutions to take the coordinate system in Revit. If you move that manually in there and locate it, take that coordinate system and override the coordinate system of the point cloud. So from that point on, everyone on the team will bring that point cloud into the project using shared coordinates. 2 years from now, the client calls you and says, "Hey, Kelly, I just removed this point cloud." It happened to me. I removed this point cloud, and this was a project where we actually moved it manually for some reason. So I had to send him a list. Load this level, move it 5 inches down, rotate it this many degrees, which is if you lose those translations, you're done. So from a setup perspective, that's probably one of the most important things. And the goal is at least 95% of the objects to be placed orthogonal. As Larry said, that will save you a lot of time and cost by placing those objects orthogonal. You can dimension to them.
Yeah. So in the setup, one of the things we usually establish is sort of a reference plane line that everything's going to be dimensioned to. And what we found was we had essentially two types of clients, the majority being the architects and engineers that want even dimensions. And when it's, you start getting dimensions like 1/256, it aggravates the hell out of them. So what we would do is we set up a reference line and make sure that all the elements that we place are within, and it's typically like a 1/4 inch, tolerance. Less than that, most things are going to end up being slightly out of it no matter what. So that's typically what we'd hold to. Now we do have some clients that are very particular, and they've got tolerances that are gnat's ass. And in that situation, we'll match the point cloud as closely as possible. But for the ones that are more concerned about having clean dimensions, we tell them, okay, we're gonna model to, a reference plane and make sure that it's getting as clean the dimensions as we can. But when you hit a high tolerance area where accuracy is incredibly important, you need to turn that point cloud on and see what that wall surface is actually doing. Is it tilted? Is it bowing? It may be a stone wall where there is no flat. Where do you put the Revit clean box wall? And so is the stone sticking out to where you're gonna hit a dimensional problem with your accessibility? So that's one of the biggest first things that we establish, and then everybody's to hold to it.
Larry, do you differentiate between the roughness of a surface, let's say a jib wall versus a masonry wall, and does that come into play how much you're rounding? What is that module that you're using when placing and dimensioning elements?
Well, stone walls in particular are when you've got a rough cut faced wall, are a challenge for people to decide, where exactly should we put that neat Revit, plane. As far as dimensioning like let's say a flat brick wall, and and a plaster wall or a stucco wall, yes, we absolutely do try to determine and put in the Revit model that surface, because I think it helps people understand the model much easier as opposed to making everything a generic element. My team's only to make it a generic element if they truly don't know, but I also harp on them, do not guess. If you do not know, do not, then it has to be generic until we can determine for a fact that it is one type or another. So that's the better way of going about it legally.
Yeah, and I'm curious, Dustin, when doing more civil work, I assume the same thing applies, because you'll have laser scans of bare dirt, and you'll have laser scans of gravel, and laser scans of grass, and laser scans of all sorts of stuff, and you're trying to generate topography or all sorts of things from that.
The tolerances are a little different, but absolutely, it's so one part of that is it's really nice to have a classification of what those things are in the point cloud classification. It's super easy to see in most software these days. And then when you're extracting out the information, we're in inches, not millimeters. But I think somewhat to that point, and building off of what Larry and Sylvia was saying, for like the VDC or even at the design stage, so the most successful, least friction projects I've been on have established real world coordinates early on from a surveyor and communicated that in some sort of document that lives with the project, and then it's transparent to future laser scanners, what if that's not the same as the surveyor of record, which it typically isn't these days. And then that way these models can be shared easily in a common data environment, and when they're brought in, it just comes right into place. It's simply a communication at that point to be able to do that.
Yeah, no doubt about it. Couple other points.
Coordinate systems. Sorry.
Yeah. A couple other points I want to hit real quick before we jump to the next topic. Another thing that I always like to talk about is, inside of Revit, right? There's the ability to demo geometry. You of course can't demo a point cloud, though you can make regions and like hide them and do things like that manually. Though we did actually show a cool hack by which we can get you demoed point clouds. I think we showed that in either the last webinar or the one before that. If anybody's interested in that, reach out to me. But one of the interesting debates is like, well, should your existing stuff be in a linked model, or should your existing stuff be in the main model? I'm a big advocate for existing stuff in a linked model. And yeah, it stinks that you can't just put a door in a wall and it will automatically cut a hole in the wall for you, and that'll be demoed in your demo plan and everything else. But the real world doesn't work that way. You don't cut a hole in the wall and magically the door fits into it. And existing walls and new walls don't magically join together when you make a new wall. And so I really am an advocate for having all of your existing in a separate model, because then you have to be really intentional about when you interact with the existing elements, your new elements in a new model. And if you need to put a door in, well, then you need to demo out a bigger hole anyway. In the real world, you'll cut out a bigger hole. They're going to need to put in bracing for the door. They're going to need to put in a header. They're going to need to do all this stuff. So you cut a big hole out of the wall, and then you put in a short bit of new wall in the new model, and then you put a door in that. And that's, A, a more accurate representation of how it's going to get built. B, it allows you to really kind of control, well, where is that? How big do you want that hole to be? How big can it be? Is there a light switch there that's existing to remain and you can't demo that? Well, you need to shift the door over. So it forces you to think through things, I think, in a more intentional way. It's a little bit of extra legwork, but it's one of those things I think pays dividends. But Larry, Sylvia, Dustin, anybody want to volunteer counterpoint or shoot me down?
Well, if you're, I think that's a great idea, and I like what you've said there. In some situations where people decide that that's not the route that they want to go, phasing becomes super important. And so setting it up so that ahead of time, before you begin modeling, that all your views are on existing. And then that gives a person an opportunity later on to do a demo and then a new construction phase is really important. And I
still advocate for setting up phasing even when you have it in a linked model. It gives you an extra layer of separation. But yeah, phasing is super critical.
Yeah,
Kelly, I think that's a great idea. I mean, I had situations where the client wanted to get into the model to use what we've modeled just a week after we started. It was a fast track, so they needed that information sooner than later. And we were both working in the same model, different phases, but that still created some issues with their new design walls joining with ours. So just I think your idea, especially in those cases, to keep those separate, it's a great idea, because now I think more and more clients, they've asked to put the model on BIM 360 being live, and they can just jump into the model and start their design as soon as they have a minimum level of information created by whoever is scanning and modeling. So separating the two models might be a solution for those situations.
Yeah, the tough problem that we have is that, you know, we're a consultant that starts, we're the first boots on the ground. And we create a model and then we hand it off to a design team. And if they're smart, they'll link it in, because we may have updates later on, like an area that we had to go back and rescan because they've done some work on site. And if it's a linked model, it's no big deal. They just update the link. But a lot of times clients will immediately just start modeling over what we've done. And then, you know, there's a bit of a mess that happens for them. So, but
yeah,
we don't always control that.
Yeah, I know. Clients are going to do what they want to do. Let's talk a little bit about manual extraction stuff. We talked about this a bit in the last session, just to kind of explain the automated extraction tools. So if anybody wants to learn more about automated extraction, the last session that we did focused on some automated extraction and meshing and some different things that you can do to kind of pre-process. But manual extraction, when you hear people talk about manual extraction, right, that's where you as a user basically selects or windows or identifies a set of points in the point cloud, and then an algorithm figures out to some extent what to put there. Now, most of these tools are not smart enough that you can just grab points and say, magically figure out what it is. It's like, you got to say, oh, I want to extract a pipe, then you have to window a pipe, and then it'll give you a pipe and it finds the diameter, right? Or, oh, I want to extract an I-beam, and then you go window it and it'll try and size and place an I-beam. These tools are really, really useful. And we talked earlier about the kind of balance between accuracy and representation. What we didn't talk about, and what's super important relative to these manual extraction tools, is also speed. Because I guarantee you, while the manual extraction stuff is more accurate than a person is going to be eyeballing stuff, generally speaking, it's way slower. So it goes back to that balance. Sylvia and Larry, Dustin, I don't think you and I have talked about this, though you played around a little bit with Edgewise recently, but I know a lot of the Flatscape stuff also has some extraction tools as well. But I'd love to hear from each of you kind of how you balance, like how much of your projects, and Dustin, we'll start with you, but like how much of your project work is done using kind of extraction tools versus how much of your kind of project work is done just with manual, picking points, tracing, eyeballing it, dimensioning, all that kind of stuff.
So back when we started doing laser scanning with like the C10s and, a while back, it was much more manual, because that's one, the tools weren't really there, and the ones that were not as reliable as we needed them to be, especially since at that time we were professional land surveyors, so there's another level of accuracy needed. And but these days we're probably in like the 75% range of doing an automated extraction, and then trust but verify. Definitely like diving into the models and reviewing them and knowing what those, like after using those tools, you know where you need to look to make sure that they are accurate. I think that anybody getting into using any of these tools is really, I think, using the best software that will let you be really fast at interrogating that model and extracting things out. Knowing that there's going to be this manual bit that if you can really master that program, you're going to just be flying. Even if it is a manual process, I think you feel like you can trust it more in certain areas. And then being able to like repetitively use those extraction tools that automate some of those things, just knowing where you need to verify more, let's say, and then there's a component of what kind of data you're getting in to extract. So I'm just going to use civil, like curb lines can be difficult, right? So you're deriving point clouds from maybe a photogrammetry, and that may, like, depending on your level of accuracy and density, you might not want to represent tops and bottoms of curb lines or things like that. And that's true across the board, I would say, right? I think it's really beneficial for people to get out into the field early on too, and do some laser scanning and see what it takes, so they can tell if they are doing this thing where they're sending out a field crew, what do you need to ask them to do? Early on, I think that's super beneficial.
Yeah, Sylvia, you want to take a stab next, and we'll polish this one.
Sure, yeah. So, I mean, Kelly, the two of us talked a lot about this, and that my dream is to have one button that I can push, and it could generate that model. One button, the magic button. But I think right now, the amount of automation and semi-automation that you can employ on your project depends on two things. One is the type of building, and the other thing is the discipline that you're modeling, right? So if you're doing architecture, that might be a little bit more challenging. If you're doing a historic building, that might be a little bit more challenging. If you're doing structure, steel, concrete, with profiles that are extruded, that's definitely going to determine the percentage of automation that that project will incur. But if you're modeling a castle, probably automation is going to be close to zero, and a lot of that will have to be interpreted by the users, and hopefully they will have the background and experience to interpret and model that building. So, the type of building and discipline will determine for us the percentage. So if we're doing a hangar, aircraft hangar, probably, you can automate 70-80% of the steel in there, and piping, and everything that can be extruded.
Yeah, I'd say the place that we still find the most useful is when you've got a large piping project. Pipes are really easy for the computer to sort of find them, especially with something like ClearEdge. And while there's still, I want to make it very clear to people, it's not 100%. You still have to go through and identify the types of pipes. If there's a piping spec that you have, that's great. You can, determine the type of pipes, but letting the computer find the cylinders and locate them is, I think, that's to where it should be. So that's, and then ability to extract is getting better and better with the different types of things that we can extract. But we're still, as an industry, we have a ways to go.
Also, Kelly, I'd like to add that the benefit of extracting these profiles using some sort of software like ClearEdge is that it's going to match profiles with to a library. You're gonna look to a library and it's gonna tell you what diameters that are actually out there that exist, especially for steel. I mean, how do you do that manually? I mean, you have to measure your flange, your web, and look through your list of profiles and see which one is closer in weight to those dimensions that you took from the scan. It takes a long time. It can be done, but it takes a long time. So that's another benefit. If you can use those tools, it will help you to match profiles to some sort of library or standard for the region that you're working in.
Yeah, definitely. And I think the thing to remember with these extraction tools is they're good at things that we aren't good at, and that we're good at things that they're not good at. So at least for the next 5 to 10 years, they're really tools that complement the human. They're not tools that replace the human.
Right.
So it's really using them accordingly, right? It's using them to complement the person, and help them be more accurate. Find the right steel type in the catalog, do the optimization to find it, et cetera, et cetera. All right, I want us to dive to some manual tracing over the point cloud, because the reality is we spend a lot of time, as we've all said, doing that still. It's probably where the biggest chunk of man hours go in on the project. And Silviu, I called it performance art in one of my social media posts, but Silviu volunteered to share his screen and to actually open up a project and maybe do some on-screen modeling and kind of talk through, and with us kind of throwing grenades at him, talk through some of that kind of thought process that goes through tracing over a point cloud. Do that for a couple minutes here, just to kind of help people get a little familiar with that.
All right, yeah, I will do that. So what you can see here, this is a very, very simple project. The reason why I'm showing you this project is, sorry if you can hear some background noise, but this is a project that is very unique from the standpoint that I found deviations and deformations that I've never seen before. So we have this building, instead of being rectangular, is actually a parallelogram, and the walls are leaning in. So there's some sort of pressure on the foundation walls that force the foundations to lean in about 4 inches, which pushed the entire building and deformed the entire building. So the client didn't know this, so we looked at the point cloud and we started to set the coordinate system and make sure that those 95% of the walls and objects are orthogonal, and we were not successful. So then we had a conversation with the client. We said, hey, 50% of these objects will be outside of the LAUD 30 range if you want us to model them orthogonal. They said, yeah, we want them to be modeled orthogonal. So that's what we did. So we did our best to model them orthogonal so they can use them for documentation. So the first step, in manual tracing is, you look at your floor plan. This is kind of, there's a lot here. So there's some paneling on these walls. You don't know exactly how to model. Obviously, you need to pair Revit with either 360 views or with recap to be able to understand what's inside those rooms. You cannot do one without the other if the point cloud is questionable. But the first thing is make sure that you set your view range to a slice thin enough to eliminate either paneling that's lower or baseboards, things like that. So obviously here I like to set mine to about 1 foot, and sometimes I do set the view range, the slice, to be a lot thicker, because I want to understand if the wall is actually plumb or not. That way I can place it even more accurate. And as Larry mentioned, is if you're in the field, sometimes you can tell what type of wall you're dealing with. Sometimes you cannot. If you don't have documentation, you'll not be able to. So on this side, still you can see the paneling, which is nice and smooth. But being there and seeing how these were constructed at a lower level, we could see the wall types. We were very confident that they used a stud jib on both sides, and they placed the paneling on top of that jib. So just pick your wall type that matches that. So that's going to be a W4A. All right, so this is the wall type, and make sure you set obviously your base and the top constraints right. And I always like to align it to the location line to be set to one of the finish faces, exterior or interior. That way, if I need to make an adjustment in thickness, I make an adjustment and the wall moves in only one direction, right? So if I pick that corner and I trace it all the way to the end, like you see how much off we are here. So so you need to find that balance. If you want this wall to be orthogonal, you're just going to push it until you find that balance where you minimize the error at one end and at the other end. And as Larry said, we do the same thing. We dimension the face of a wall to a reference plane. That will give us, a nice and rounded dimension. We do 1/8 of an inch modules for smooth surfaces, 1/4 for rough surfaces, right? So that's what you do for walls. Once this is in the final position, you're gonna start tracing all the other ones, and move down to your finishes. You're gonna move down your cut plane and add the finishes. And you see here that if I switch to, let's say, the model that's actually complete, I have another one here. So this is the model that I just looked at. Right, the upper level. You'll notice that we model finishes separate. If we can determine what types of finishes and what thickness those finishes are, we like to model those finishes differently, especially where we have exterior walls, exterior cladding, backing wall, and finish. That way, it will give the client more flexibility if they only want to demo the finish or the exterior cladding. But yeah, it's a balancing act, right? So you have to use both recap to understand the space that you are in. So usually you just jump in one of these real views in here to better understand your space, and then you can pick the wall types, finishes, whatever you need to model. So and you start in terms of how we build these. This is something that I think, Kelly, we were supposed to cover, but I think we forgot, is the way we build the models, existing condition models. We try to follow the sequence of work that mimics the construction of the building, right? So you first model your structure, and then you enclose the building. You model your partition walls. Finishes always go last. There are situations where it makes a lot of sense to first model the envelope, because as in this case, let me switch back to this building. If I go to some of these corners, you see that I'm off by about 2 inches and about 4 inches on the other side. So yeah, I need to make sure that my envelope is first modeled. And if I need to model everything orthogonal, I communicate to the team, like, hey, these walls are not orthogonal. So when you model any elements that are adjacent, so to go to, let's say, the lower level, because this is the worst, this wall here, this wall is bowing in by about, 4 inches. So when you model this small room here, make sure that this wall is relative to that one. If you're going to match the point cloud here, you already introduced error in the model, a lot of error. So everything has to be, all the objects have to be relative to the object around them. So it's challenging. This was probably one of the most challenging models to to make sure that things were relative to each other in terms of dimensions. So,
and so the reason I wanted Sylvia to show something like this is because, you know, I think people assume that when you're modeling from a point cloud, you know, you're just tracing the points, but it's not that simple, because the points are more accurate than people want things represented most of the time. And so, you know, you've got all these decisions that you have to make on the fly and assumptions. Sylvia, while I keep talking, can you hop to like the assumptions page, or, you know, show one of those view filters?
Yes.
Yeah.
Let me.
Yeah.
So, for instance, this is not my idea. This is Larry's idea, and I just implemented on some of our projects where we have a set of parameters that we use in order to tag various conditions that are outside of outside the spec, you know, accurate but not orthogonal. Maybe we did some orthogonal corrections, things like that. So, you know, you select a wall, and if this was was adjusted in any way from where it's outside the spec, you just check one of these boxes, and it will be color coded and shown in these 3D views, and the client can come in here and then, you know, turn on and off elements with no deviations and only see these elements. They can see them in their own, you know, isolate and see them in their own views, and it's a very easy to understand, you know, why we model things the way we model. But also, we like to document things in a written format, things that are very hard to be shown in a 2D or 3D view. So, you know, if we found any deviations, we need to explain what we found so the client doesn't call us later. So anything that we find in terms of observations or assumptions, we will document in a legend view. That way they can always read this, and you maximize the transactional value at handoff, basically. You try to minimize that learning curve when they get this.
And guys, I'm going to jump in. We've got about 2 minutes left of scheduled time. So I do want to hit one question before people start dropping off. We had a question about, you know, QA, QC, because that's obviously an important thing. We've just talked about all this modeling stuff and QA, QC, and, you know, ultimately, just so to give a quick answer, and we can continue after we do the goodbyes, but because everybody I know has some great points and tips on this, but you know, there's a lot of slicing and checking and manual observation. This is one of those things where, you know, it's very important to QA, QC the results, and particularly like if you're dealing with a situation like Sylvia showing where, you know, well, one wall on the interior is modeled 4 inches off, and that looks like a mistake, but it's not a mistake, because actually the wall on the outside is modeled 4 inches off. And if you don't model them both off, then you're giving the customer the wrong square footage for a room. And so it's not necessarily an automated process. There are some tools that help with that. So I get to brag right now on our software, because that's the privilege I get from organizing these things, is every once in a while I get to do that. So this is actually a heat map generated in our software, Verity. So one of the things we use this for is you can take the point cloud and the as-built model, pull it into Navisworks, and then run a comparison between them, and then color code the actual points to show you where there's deviation between the model geometry and the point cloud. So you can, you know, you can certainly, I love the filtering at the geometry level, but the whole wall's green, right? Or the whole wall's red, and that's not usually the case. Usually part of the wall is fine, part of the wall is not fine, because the walls aren't flat. And so, you know, this lets you pretty quickly go in and understand, you know, okay, well, this wall definitely is tilted and slanted because the bottom of the wall is fine and green, and the top of the wall is red and it's out. And, you know, the roof here is not very accurately modeled because it's mostly blue. And, you know, you can kind of dive into each of these things. This also tells you interesting things about texture. This is a rough ashlar wall, right? So, you know, the stones here are out, the stones there are in, the grout is inboard of that wall. So it's, and this also gives you an element by element breakdown inside of the Verity software, where it'll actually show you each wall how much it's out as an average to those points. So if you want to automate part of your QA/QC, this is a super great way to do it. You can kind of process it in the background. When it's done processing, you can kind of review. It'll show you which elements are really bad, and then you can export some stuff out like this as a deliverable to help people understand it. So QA/QC is totally a big thing, but this does not, again, replace human oversight, because there are other things that need to be checked for, as very well demonstrated by Sylvia's crazy project with 4 inches of bow in a wall. Let me do the quick goodbye here, Sylvia, and then we can continue. So we are at time, 1 minute over technically. So thank you everybody so much for coming. I think we peaked at about 160 people sitting in live. I see people are having to drop out to go to other meetings. So we're going to call a wrap on the regular content. We will do, we've got a whole lot of questions that came in, so we will spend at least another 10 or 15 minutes answering some questions. All of it's recorded, so don't worry, you won't miss your question getting answered. If you have to leave now, the recording will be out in a week. Also, Sylvia and RC Monkeys are our Q&A sponsor for Scandibim University. So all the Q&A actually goes to Sylvia at the end of this, and Sylvia will write some answers to this. This will be posted on our Scandibim University LinkedIn group. So please also take a look at that. And then last but not least, please head over to scandibimuniversity.com for upcoming sessions. We've got one left in this series, and then we're going to jump into some other stuff, and we'll talk about what that is after the next class. But our next one is on deliverables and turnovers. So we are going to focus on interesting turnover and deliverable items, things like that. So that'll be next month, same bat time, same bat channel. And I hope to see you all there. Thank you. If you have to go, thank you so much for coming and attending and your questions. And if you can stick around for a little bit longer, we will let the rest of the panel answer the Q&A question for a minute or two, and then we will dive into some of the other questions, because there's a couple really good ones. So actually, there's a lot of really good ones. But yeah, so thank you all so much. Panelists, if one of you guys have to bail, totally understand as well. Thank you so much for your time, and happy rest of your Thursday to everybody that's got to go. Sayonara. And with that, Sylvia, I cut you off.
No, that was Larry. You cut Larry off.
Larry, I cut you off. I'm sorry. Larry, go.
Well, just adding to both what you and Sylvia said, the idea of one of the things I tell the junior modelers, if you have to make a decision as far as where to place the wall, because it's not orthogonal, it's leaning, it's at a plumb, always err to the giving them less space in the room or wherever it's critical. Because if they go in with a piece of equipment and suddenly they have more space than what they had on the drawings, nobody's going to complain. But if they go in with a piece of equipment and you've erred to make it look like they've got more room and it doesn't fit, there's going to be a big problem. And so that's
a good point, Larry.
If you've got to err in one direction or another, always make it look like they've got less space. Is sort of, you want to be as accurate as possible. That's, everybody wants accuracy. But at the end of the day, we are creating, these sort of diagrams that are symbolic. And if they want the reality, again, they must turn on the point clouds, and then they can see a much better representation of exactly where that stuff is, and still have their dimension strings work.
We do a lot of work with the construction guys, and they're doing this offsite fabrication where most of the materials they could cut down, but they can't make any bigger. So there's it's definitely depending on the application, that's a whole different ball game. So yeah, assumptions are critical to convey for sure.
Yeah.
Yeah.
What are some of the questions from the audience, Kelly?
Well, that was one of them, was on QA/QC. I think, you know, we've got another one here that's, I think, fantastic. After modeling, but prior to for finding, so QA related, what are any other strategies, tips, or tricks for QCing the extraction? So Larry, you'd made, or it was Dustin had made the point about, you know, once you use the tools, you kind of know what they're good at and what they're not good at. So how do you QA/QC the manual extraction as opposed to just the human tracing? Because you are looking to QC maybe different things and the error profile is different.
Yeah, I think the heat method that you showed up, I think that's really where the automation is super powerful right now, is really indicating to the humans, like, this is an area you need to look at. So we have some of those same things in the civil side. It's just very similar. There's differences in dimension from what is expected or what was existing versus proposed. When it's more like line work or things like three-dimensional line work or planes or things like that, for the most part, it's just flying through the model and knowing what to look for. It's the experience of knowing what needs to be there from seeing lots of different projects and interrogating it with, you know, being able to fly through something very quickly and see those differences that might exist from what you want.
All right.
Also, Kelly, sorry, since we're on the quality topic, one thing that you know, nobody asks, or, you know, we're talking about quality, but what does a quality product mean? Because that can mean so many things for so many people. We're only discussing about how well an element fits to the point cloud, but that's only one aspect to what defines the quality of a product. And there's so many other things. Like, some people might look at, you know, the first thing they might do, open your warning dialog, and you give them a model with 1,000 warnings, right? So there's so many aspects when it comes to the quality of, you know, if you're delivering a model, like, how well is this model assembled relative to how buildings go together, right? Dimensional accuracy, naming convention, how, you know, how are you using the right line weights when you're building the families? Because there's so many things that make up the model. It's not just the geometry that fits to the point cloud. So, you know, quality assurance, I think, is much more important than quality control. Because if you have a good quality assurance program and guideline for your team to follow, then there are, you know, a lot less things to be checked. You still need to check things, but a lot less things to be checked. So yeah, the quality is a very complex topic, and it can mean different things for different people.
Yeah, but I want to jump on some project planning stuff as well here. So we have a question about from Brennan about how often are LOA and LOD within a project varied. For example, room A needs very high LOA, LOD, where room B is a very low LOA, LOD. Do you see that a lot? And maybe additionally, how do you handle that when doing your BIM execution plan and your LOA, LOD documents for that project?
Can I take that one? Yeah, so what I found is the larger the project, the more opportunity there is for that. So like, we were, at one point we were working on, it might have been New York Public Library, or we were working on the Metropolitan Art Museum in Central Park. Both of those were like 1 million square feet projects. And so what the client, which in that case was Buyer Blender Bell, an architecture firm there, they actually drew up plans and laid out, you know, in color diagrams, this area is LOD 300, this area is LOD 200, this area was critical for, you know, a high level of accuracy. This area, you know, we don't want to spend as much, we're not going to do as much there. And so the larger the project, the more likely that's to come into play. And then a way of handling that is to have the best way of handling that to communicate between you and the client is before you even start to do sort of a general floor plan and outline in color or somehow differentiate what are the LODs and LOAs for those areas.
Awesome.
Yeah.
And Sylvie, if you would, Mark McNulty had a question. He said, so you model a wall with finished material abutting a wall with core material? ? So the two levels where you have a finished wall and you had showed that on the screen, Sylvie.
Yeah. So what was the question again? I'm sorry, I didn't follow the question.
I think he's trying to understand how you're doing that. So I think I understand the question, so I'll cheat.
I mean, yeah, if it's a finished wall butting into another wall, I just disallowed, joint of the finished wall.
Yeah, and the other thing, if you have two walls, for a finished wall and a core wall, or a finished wall and a structural wall, if they are right up next to each other, you can lock and align them so that they move together. The other thing you need to do is join geometry. If you hit join geometry, then an opening in one will cut the other. So there's tricks around this, but yeah, Mark, this is it's not something you necessarily want to do all the time. But if you've got a customer that's going in and they're going to demo out the finishes, but they're going to leave the core wall, well, you don't want to model it all as one monolithic element, because then the customer's got to modify and completely redo your model that they've just paid you money for. So this kind of goes back to understanding what the client wants to do on the project and then making modeling decisions according to their end use. So if they're like, yeah, we want to leave the core walls but rip out all the finishes, that tells you, I should model the finishes as one wall and I should model the core as a different wall.
On the interiors, there's a judgment call for a team, and as to whether or not you do that. We find that on exteriors, it's even more common that we have to break it in two to three walls at times in order to be able to get a model that's really useful. So as opposed to modeling the exterior wall with one single wall type. So yeah, it's a very useful idea as far as not just using one wall type, because finishes will change from room to room. Places where the client wants to handle, they may want to demo one room but not the room next to it, and so it's a very useful technique if you haven't tried that.
Also, Larry, by doing that, people might assume that we're using more wall types, but we're not.
Right.
Yeah, you're using less wall types. As you said, you don't have to create a wall type every time the finish changes.
Right. That's a great point, because that is a major complaint amongst clients. Once you start using, 1,000 different wall types, it can upset them. If the more efficient you can be with your wall type, the better.
And especially for the exterior cladding, you can do, while you're in the field, you can use brick, right? Brick is kind of, it's modular or standard. You can make some assumptions, at least to represent the cladding. What's behind it, you can use generic.
Right. And that's an important point. The idea of using generic for the core, again, you should not guess. If you don't know, then it does need to be generic, in that it lets the client know, hey, more before I say I'm going to attach something heavy to this wall that cantilevers out, we're going to have to go in and we're going to have to figure out what that actually is, as opposed to making assumptions, because assumptions are what get people in trouble. Yeah.
Yeah. Also, let's see here. Guess that's a question for another day. There used to be some tools, there we go. There used to be some tools back in 2012 in AutoCAD that produced simple primitive extractions. Are you aware of simple and expensive primitive extraction tools? So like say for instance, you need to model a pump and you don't care about what model, specific model. You don't want to go find a manufacturer, download a block and do all that stuff. You just want to rapidly kind of model up the surface geometry or model up a solid geometry model of something in a point cloud that's a little complex thing. How do you guys handle that right now? Anybody want to take that?
A mesh. I mean, you can do a mesh. I think Paul Alban, he has a class on this. Paul and I, we've been attending some workshops in Italy, and some of those surfaces are very complex, hard to model. So he brought that into he turned it into a mesh, brought it into 3D Max, turned off all the interior edges, exported it as a DXF, loaded it into a family. It cuts very nicely. It's a low size file. So that might be one solution to represent something that's more complex that you don't have time to model it. To use just regular workflows.
So fire hydrants can get tricky, but it's important to know what kind it is. You look at it from a plan view, it's just a generic two-dimensional symbol. Flip it into a 3D, and you don't have to have a point cloud. And anybody with an iPhone can do a 3D mesh now to just get a representation of that hydrant or other site pieces.
Well, that's actually a really great point, Dustin, on when you're dealing with something that's like a componentized thing that you want to reproduce, because this is where kind of your super low end reality capture stuff, when you're dealing with something small like a piece of equipment or a pump or a fire hydrant, it's more than good enough, because while the accuracy isn't great at range, the accuracy up close is actually pretty tight. And so thinking about that from a modeling standpoint, a great mechanism to do that is like, oh, you see a fire hydrant or you see a particular pump and there's 30 of them in the room. Pull out your iPhone, get yourself a mesh of that pump with your iPhone, and then save that. And then when you get back to the office, take that mesh of that pump into a family, and then place that family 30 times for all the pumps. So there's some really neat workflows where you can kind of do these hybrid capture modalities, and then as Sylvia said, use a mesh. I do know there's some tools that do this, but again, my gut sense is that Stephen, is that you're better off time-wise just doing a mesh, or you're better off tracking down a make and model number for that thing in the field and just writing it down in your notebook, and then doing a search online, because almost everything now you can find CAD geometry for it. And if you want CAD geometry, just search for the son of the just search
hopefully you can get your hands on the cut sheet for that make and model.
If you get it from the manufacturer, make sure you simplify it before you put it into your own project, because they love those screws. They love those little, tons of detail that when all you typically care about is how much space around that thing do I need. So, that's the big deal. But yeah,
you always wonder, Larry, who builds them? I haven't met anyone that builds those, those families.
Oh, there's, sometimes they do it in-house. There are a couple of guys out there that they contact manufacturers and offer to build their computer models. But that's, they consider that fun. I don't consider it that fun. But yeah, for sculptures and gargoyles and things like that, building elements that it makes the building computer model look cool. Yeah, we go the mesh route for those sort of little details.
Yeah. A quick business question here. What plan has to be taken in hand if a client raises the LOA above what was agreed to in the BEP at the beginning? Well, the answer is that's a change order. You charge the client more money for it. If they raise the LOA, that puts more demands on you. It takes longer to do a higher LOA or LOD model. That's a change order. That's why documenting these things is so critical. That's why I recommend the USIBD documents, because that will help you thoroughly document it, and then you have grounds for a change order. And the client doesn't want to pay. They're saying, well, they don't need that level of accuracy. It just takes more time to make a more accurate or more detailed model. And
also,
then
Kelly's like a what if, I use a what if, like, okay, we can do that. I mean, we can do a change order, but do we have any existing documentation that we can use to increase that level to LOD 300? Do we need to take any field notes, photos, anything that can help us to achieve that level? If the answer is no, I mean, they would want that level, but we cannot achieve it.
Yeah. Well, and is the capture even sufficient to it? Because, you'll go out and if somebody tells you it's LOA, 10, you can go out and capture, don't do any survey control, just go blow and go, get scans with reasonable overlap, cloud to cloud, the whole thing, and not worry about it. And then they come back and say, oh, well, we need LOA 30. And you're like, I have to go back out and scan, because now it's a big enough job that I don't have survey control to, guarantee LOA 30, over the whole building. So now you've just told me I have to go back out to the field. That's another trip. There's reimbursables associated with that. That's, I've got to do more scans. I've got to rent a total station. I mean, and so it's super important to get that stuff narrowed down at first. For all those reasons. I think we got, let's knock off one more question and then wrap it here. And then anybody else with questions will follow up after the fact. Let's see here. I find, actually, this is interesting. I've yet to jump on the Revit train, as most of my work is still done in AutoCAD, but Revit's becoming increasingly requested. What are your recommendations on training, learning options? Also, what plugins would you recommend? Dustin, I know you don't do much in Revit, but you do a little bit. So at least you did on the project with Nathan. Actually, that's probably interesting, since you're just kind of playing around with it. Do you have any kind of recommendations of somebody that doesn't do it very often, but's messing around with it on the side?
Yeah, so the question was, what kind of plugins were, so on that particular project, it was very similar to the one Sylvia, it was a residential project, and we did some automatic extraction with ClearEdge. As far as training, I don't know, what is it, the Bible to AutoCAD was you just get, learn by doing, and then having a reference manual is how we did it, 15 years ago. So as far as training goes.
Yeah, for Revit, I know Sylvia mentioned Paul Aubin's got some great Revit training stuff online through LinkedIn Learning. There's also a couple of Revit, Revit Bibles. Sylvia, anything else you want to add to that?
I mean, you can. I always recommend starting with the fundamentals. So LinkedIn Learning is a great place to start with that. I don't know if Udemy or other platforms will offer Revit training, but LinkedIn Learning, it's a great place to start. And then once those are exhausted, you can use reference manuals, or just contact other experts that are willing to train you, like Aaron Maller, or other people like that will take your skills to the next level. But LinkedIn Learning will be sufficient to get you started for most disciplines.
Yeah.
Larry, what are you recommending?
With me? What?
Mm-hmm.
Any training plugins?
No, but I will say that, look, 3D scanning becomes a lot more efficient, economical, and interesting when you're working in 3D. Okay, if you're drawing 2D plans, running out with a disto that might be the most cost-effective thing to do. But when you're 3D scanning the building, the 3D modeling that you do in Revit becomes a lot more efficient and economical to be able to understand, and your whole process speeds up. So it's There's a number of reasons. I could go into 10 different reasons why you should make the switch to Revit over AutoCAD. But then there are people where AutoCAD totally makes sense still for. So depending on your use, but if you're the average architect or engineer, there's a number of really good reasons why you should be making the change, and you should have made that jump already. You're actually behind times.
That's a good point.
I can't be nice about it anymore. At this point, I just got to be blunt and tell people you're either planning on you're not thinking about changing to Revit, you're thinking about retiring, or get into it, because that's the efficiencies and the economy of doing it are way outweigh whatever time it's going to take to train for it.
Yeah, indeed. And with that, we are already 26 minutes over, so let's wrap Q&A. There's a couple other questions, but as I said, Sylvia has graciously sponsored, and we'll comb through the questions, and we'll have posts for those on the Scandibim University LinkedIn group, Twitter, LinkedIn, et cetera, over the coming weeks and months. So yeah, and then of course, always feel free to reach out to our panelists. They are here for a reason, and they're here to share their knowledge. So you can find all of us on LinkedIn and Twitter and other places. Please track us down, follow up with us there. We're happy to continue the conversation through other venues. So guys, thank you so much for your time today as panelists. And with that, I am going to kill this thing and let everybody get on with the rest of their day. So adieu to all.
Thank you, Kelly. Fun.